Thank you for coming. And so my name is Gabriela de Queiroz. I'll be talking about deep learning with Keras. So for now, you already know deep learning a little bit by the excellent lecture that Julian gave us. So you know a little bit about like convolution network and all those things. I'm going to talk more about applications and how to use R for that. So just to give you an idea who I am. So I'm a senior developer advocate at IBM. I work for Center for Open Source Data and AI Technologies. It's called Codate. Everything that we do there, it's open source, it's free. We have several projects going on, people contributing to open source. One thing that people doesn't know, like they don't know that IBM, it's one of the top open source contributors. Just to give an idea, there is one person in my team that all he does every day, all the time, it's to contribute to some packages, some projects, such as Apache Arrow, like TensorFlow, Spark, etc. I'm the founder of Our Ladies. Our Ladies is our organization to bring diversity into the R community. It started in 2012 by myself here in San Francisco, and now we are all over the world with over 130 chapters in more than 40 countries. I was just invited to be a member of the R Foundation, which is I'm still like, I don't believe that I was invited because it's such a I've been using R for over 10 years, and it's such a pleasure to be part of the R Foundation. And also, I'm a member of the R Consortium. So I should say you should check all those links because there are a lot of good information over there. If you don't know about Our Ladies, make sure to check it out. If you don't know about the Codate Center at IBM, also go and check it out. You probably know what R is in the R Foundation, but go there and check it out. And R Consortium as well. So here, I'm here to talk about R, so I'm curious to know how many people here use R? Wow. Oh my God, I'm so excited. Okay, cool. So if you don't know what R is a free and open source language and environment. It's a very popular language for data scientists. It has more extensions than any other data science software. Just to give an idea, R, it's very easy for you to extend R. So all the new research papers and all the new methodologies, they are, especially for statistics, but machine learning as well, they get implemented in R very quickly after the paper is published or as they publish the paper. So you have a bunch of libraries and packages, and you can do, I would say, everything inside R. And then we have R Studio, which is an IDE that you can use with R, and there are a lot of functionalities. And I'm going to touch a little bit about some of the functionalities that you have inside R Studio that makes our lives as a data scientist, as a developers, a lot easier, right? So, and then the last one is the community. So one of the reasons that the language also is growing and being so popular these days is because we have a huge network of developers. So R stats in Twitter, you can check for the hashtag. Our Ladies itself has a huge community, and then we have R Forwards. And there are other communities more specific, but this is like the general communities that we have. You are probably asking yourself, you've been seeing a lot of talks around deep learning, around TensorFlow, Keras, MXNet, and other deep learning frameworks. You are probably wondering, can you do deep learning with R? And why TensorFlow? So one of the reasons is the TensorFlow API. So you have Keras APIs, which is a very high friendly interface for you to use. You have some estimator API that I'm not going to touch on estimator and core API, but it's good to know that you have this infrastructure that you can take advantage. And then Core API, it's about the graph, and you can check it out, the Greta packaging R to learn more about the computational graph side of things. And today I'll be talking more about the packages and the supporting tools that you can use inside R. There are a lot of interesting stuff that you can take advantage. Some of them, let's see if this is going to work. So like I'm going to talk about Keras, and then some of the tools here, TF runs, TF deploy, and I'll just mention CloudML. I'm not going into detail, but I'm going to touch on those three things which are, for me in particular, are awesome. So you also have like TF estimator, where you have implementations of the TensorFlow API for regression and classification. You have the TensorFlow itself with the computational graph piece. You have the TF data sets that provides you a lot of like functionalities and facilities around how to create and scale your pipelines for the TensorFlow model. Then we have TF runs, where you can, I'm going to show how to run a model inside Keras, and then use TF runs to compare models. You can use the deploy one, where you can deploy those Keras model, and then the CloudML if you want to deploy your model in the cloud. So why Keras? Why Keras and not maybe MXNet or another framework? So Keras is well known for being, oops, what happened here? So Keras is, okay, slow. Okay, so Keras is well known for being a very friendly API with good documentation and easier to debug than other frameworks. Enables you like fast experimentation, allows you to run the same code on CPU or GPU, and you can use multiple backends, including TensorFlow, CNTK, or Tiano. So let's go back to the tools and workflows that I mentioned before. Now we are going to go and do like a deep dive on those tools. So the first one is TF runs, and that's my favorite actually. So TF runs, it's like how do you track and visualize your training runs? So I'm going to show an example here, but first, so how do you track the hyperparameters, the metrics, output, the source code of every training run that you do? How do you compare those hyperparameters? How do you compare the metrics across the runs? How do you generate reports to visualize individual training runs or comparison between those runs? So it's like a package, but it contains several functionalities. So like, let's say you have a model, in this case, a Keras model, and you are defining your model, and then you are going to compile your model, then you are going to train, and then you are going to visualize. So when you use you can use the source one, which is going to run the whole R script, or you can use the TF runs package and the training run function. What the training run does is it's going to pop up another window, and it's going to show us your summary, a output, and a code of your run. So for example here, you can check like the characteristic of your model, like what kind of optimization you're using, what are the metrics for evaluation, the metrics and the evaluation metrics, some information about the run, how long this took to run, how many samples, how many epochs, what is the batch size, and then you have the output. Like the output here, it's showing like how the model is as the model is running, how it's performing. And then you have the code, and this piece, when you compare two models, and I'm going to show you in a minute, it's kind of like a GitHub, like a version control. So if you have a model, like the first run A and then the second run B, and then the only thing that you changed it maybe was the number of epochs. It's going to show you the same way as GitHub shows you when you change something in your code. So like, let's say now I want to change on my original model, I want to change my layer dense units and then my epochs. So instead of like being 2, 5, 6, I want a second model to run with 128, and then with, instead of like 20 epochs, with 30 epochs. So I can use the same function that I did before from the TF runs, and it's going to show the same thing that showed before. But now I don't have like a comparison. I know what I did ran before and then what I'm running now, but I don't see a comparison side by side. So then it goes to a second function, which is called compare runs. That is also from the TF runs package. And now you can compare the two runs. So you can compare the first run with the second run. So this column is the second one, and the first column is the first one. And then this is what I was talking about. So it's showing me like the same visual, the same looking as GitHub showing like, oh, you changed this number over here from 256 to 128, and you changed the number for epochs from 20 to 30. So this is the difference between the two models. Here are all the metrics that I'm interested in looking, and here are some visual graphs for both models. So it's an easy way for you, instead of like going back and forth, you can have both side by side, and then you can evaluate which model is performing better. But now, let's say you want to run more than 2 models. Like, let's say I want to try several, like 4, 5, 6, 7 models. So instead of like hard coding on the script, like before, if we go back here, like let's say I want to change this parameter over here and then this one over here. Instead of like going to the script and then changing or hard coding, I would go and create a flag over here. So I can I'm creating 2 flags, one for dense units and one for epochs. And then instead of like, again, I going in the code and then changing, I can pass as an argument of this flags function. And then I can run, and then it's going to run using those flags. So there are other interesting things with flags. You can define a YAML file with all the flags and then run, or you can do like when you are doing tuning, for example, you can use the tuning run, and then you can pass, like for example, you can pass a list. So in this case, I'm passing the 2 numbers that I had, the original one, the second one, and then the original epochs, and then the second epochs. So I can pass a list, and what this one is going to run, it's going to run a combination. So it's going to run in the end, instead of like running 2, it's going to run a combination of, so in this case, 256, 20, 256, 30, 128, 20, and so on. So it's going to have like 4 combinations. And when you run this, you are going to get a warning saying, hey, are you sure that you want to run with these 4 combinations? Because if you have, like, let's say you have like, I don't know, 100 combinations or more than that, so you have you didn't notice that you are doing something very big. It's warning you to say, hey, it's going to take a while. Are you ready? Or do you want to change something? So it's warning you, like, make sure that you are aware that we are running a combination of those numbers. Then let's say I want to compare those 4 models, and another cool thing about this package is the ls in R, it's to list all the objects or everything that you have in your workspace, on your console. So the ls run, it's going to run, I think by default shows you the last 4, if I remember correctly. But you can specify maybe to show you the last 10 runs. So in this case, it's showing the 4 last runs that I did with some metrics over here. There are a lot of things that right now I'm not interested, but I'm more interested, let's go to the next one. I'm more interested in the evaluation accuracy. So in this case, I'm ordering all the 4 models by the evaluation accuracy. So I can see here that my first model with 128 and 30 epochs is the best one. So I can choose based on this metric which model is the best one. If you want to see like the same kind of like dashboards that we had previous, you can use the compare runs. And then what I'm doing over here, it's like compare the 2 best models. I want to see side by side. You know, it's not enough for me to see only the numbers. I want to see something else or a little bit more detail. So you can do the same compare runs, and this dashboard is going to pop up, and then you can go into more details on what is going on over here. Okay, so now let's say you have your model, you ran your model, you have the best model, and then you want to save for later, either for like to train later, or maybe you want to save to use in a different program or in a different framework. And then I'm going to show how to save, how you can load, and then how can you deploy. So the first one, it's like, how can I save the model that I just created, and I got to a point where I found the best model for my use case. So how can I save this? There is a standard format for Keras that it's HTF5. So you can save your model as a HTF5, and we can use the save model HTF5. And in this case, it saves everything. So it saves the weight values, the model's configuration, the optimizer configuration. There is a way for you to save only the weights. The function is similar, but in this case, I'm saving everything. Maybe tomorrow, I want to keep training my model. I don't have time today, but I want to continue tomorrow, so I'm saving everything. And then if tomorrow when I come back, if I want to load or if I want to restart from where I left, I can use the load model HTF5. So now you saved, you loaded, and then you want to go one step ahead. You want to deploy your model. And for me, that's from my experience, until now, that was a data science job. And now it's kind of like the engineer or the software engineer. This is when they come and help the data scientists, like how do you deploy models. So just to give an example, so at IBM, I work with a lot of developers, and we focus a lot on the consumption side of the model. So I'm learning a lot about deployment with them right now, and it's what they have been doing for the past. Not in R, unfortunately, but it's kind of like the same idea. So there is this other package in R called TF deploy, which you can deploy TensorFlow models from R. So this can be a little like a foreign for if you are not used to this Swagger UI. Don't be scared. It's just like a UI, nothing other than that, but I'm going to talk about this a little. So like, let's say you have the model, again, the model that you are happy with, and then you want to deploy. So you can export this model. In this case, I'm here exporting the model, and this is the name. It's going to export this model. When you do this, it's going to create a new folder, and then some information of this model inside your directory. And then you can serve this model. First, I would say try to serve this model locally before deploying in Google Cloud ML, for example, or before deploying any other system. Make sure that this is working. Because if you don't try here and then later on something breaks, you don't know exactly what is going on. Like, if you are sure that this piece is working, then you know that this piece is working, so I don't have to worry about this piece. I have to worry about something else. So it's going to open a Swagger UI. And what this shows you, it's like you have the model running, and then you can perform predictions based on this. The way that the Swagger works in R, it's a little tricky because I think there is some things that we can do to make this one better, at least compared to what I've been doing at IBM. We changed the Swagger to be friendly, and so you can understand even if you are not a developer. So the way that I prefer to make this one work is to serve as a HTTP post. Like if I go to the terminal, for example, let's say I have some images that I want to predict what is going on over here. So I can do like a HTTP post. It's huge, but HTTP post, I can you test it with Swagger or with the HTTP post and then deploy model. You have like 3 options. You sign in and enter your credentials and the same HTTP that we. Another option is the art option, the TensorFlow. One thing to keep and so using and serve like your coworkers. So instead of so reproducibility R markdown is an extension. I have R markdown file I'm using CI deploy. Has some counties, how so the other one got this showed you test yourself. I deployed another cool functionality for RTO, which is Shiny. You can host any Shiny or Flex dashboard you have. You can this web. So you can try this one out if you go to this URL. All right, last bonus. Let's say you don't want to code yourself. You want to see like the same thing that I showed you with the Flex dashboard. Like, let's say you are more interested in like trying things out, like seeing the final results or deploying your own model. So there's something that we are developing, we have been developing inside our team, which is called the model. So it's where developers and data scientists, they can come, they can go to the website and find free deep learning models. So of them you can make yourself. The only thing that you need to know, not even to know, the only thing that you have to download, it's a Docker, so it's to run in a Docker container. It's like small, maybe 3, and then you need to have a model that you can deploy. You have a UI, similar to the one that I showed, but it's a web app. Unfortunately, I have one running over there. Can, if I go to I have to go to my VPN, but show you the new website. So here it's going to tell you a little bit about this model, point you to the GitHub repo, all information before everything that you need to Docker, and then to deploy, you can deploy Kubernetes, or you can locally. R, Python, the same before. So, and how to create a web app. So, and it's a cool place for you to get to know if you have no idea about deep learning and how things work. It's a good way for you. You can use and go and like Python notebook with demos and yeah, 420. So it's a great for you. So thank you very much. We have 5 minutes for questions. So you don't have a mic over here, so maybe he has a mic. Is it on? I think now it is.
Now it works. Okay.
Cool.
Okay, so I've been programming in R for 10 years, and I'm a statistician moving into data science, and it just seems like Python is big in the data science world, and I've been wondering if I should move to Python, and do you see like a big impetus to do that, or should I stay in R and work there?
That's a great question, and that's my daily dilemma.
Yeah, mine too.
I am a statistician by training, and I've been using R for over 10 years, so it's the same thing. So, you know, I really like R, so I stay with whatever I like. So it's good to have the flexibility, though. Like, there are some things that Python don't have. Like, if you want to do statistical modeling, there is no way, or it's very hard to do in Python. So in that case, you have to use R. There are other things that you have in R that you don't have in Python, and vice versa. Some of the more advanced deep learning examples that I showed, some of them you have in R, but some of them you don't have, so you have to go to Python. What happens also, like, if you are working with a big team, with engineers, they will probably ask you to move your R code to Python or to another language like Scala, for example. I'm biased, but I would say, you know, stick with whatever language you feel more comfortable with, that you can work around, I guess. Yeah. Any other question? No questions? All right. So thank you very much again. If you have any question, feel free to stop me.